Welcome to another video from SkyRadar. Today we want to show you a small example how to use our artificial intelligence blocks and how to create and run a neural network which will be able to solve a classification problem. So the first block that we will need to be able to build a neural network will be the so-called AI trained data setup. In the AI data setup, we can we can input our data files, which we'll use to train the neural network. The data in this scenario has been pre-recorded in one of our customer facilities, and we can use this data to run a classification and to solve a classification problem. The data that I'm going to use to train the neural network today will be three different objects, like the big sphere, the corner reflector, and the small sphere. As you see here, I have also available another set of data, which will match the corner reflector, the big sphere, and the small sphere, but this I'm not going to use in my neural network because I want to use this data to check how good the neural network can classificate the objects that I'm training with. So after selecting the data files, which have been recorded before, what we need in the first step is to be able to set a label, right? So labeling it's a crucial point, it's a very important point, and needs to be done correctly. So we will call the first measurement big sphere. Here we'll call the second measurement corner reflector, and we will call the third measurement as small sphere. After selecting and labeling our data, the next block that we need to connect will be the AI input layer, which will prepare this data and feed it to our neural network. So the purpose behind this block is that all the data that we are inserting right here have the same input shape. What we want to do next is add the dense layer. So here we are feeding our data in the first layer, which will try to learn and derive information out of our data. We can define the units and we can choose our activation function. And then we can add a second layer, which will be also our final layer. So we would like to keep this example quite simple. And as this is our final layer, we need to match the units in the layer to the number of the classes that we have here available. And we have here 3 classes. Therefore, the output, the layer units of the output layer should be set to 3. And we need to change the activation function, which will be done as softmax. In another video, we'll try to explain what will be the differences between these activation functions and how the units will play a role in training complex neural network or less complex neural network. After we have defined our dense layers, we can go and compile our model with a AI model compile, and then we can train the AI model. In the AI model train block, you can define the number of epochs, the batch size, and the validation split. So here we have set a validation split of 0.2, which means 80% of the data will be used to train the neural network and 20% of it will be kept for validation, with which we can define the accuracy of our model. After we have trained our model, we want to save it so that we can test it with our tested data, and then we want to close the model, finish it. So what we can do now that we have everything in place, we can, after clicking in the first block in the AI train data setup, we can start the training. And now we see how the epochs are running one by one until they go to 10. And we have here the accuracy and the loss function. And yeah, now we see that our AI model is saved under the name model out number 2. So what we can do is we can pick the block, which is called AI train model. And here we can load our model, which is model number 2. We load it. And now we can go to our record and replay block. And we can find our test data, which we didn't use to train the neural network because we didn't want the neural network to learn on that. So this is an unseen data for the AI model, and we can connect it and check how good our model can classify. So these are the data that we use to train. Now we can check with some test measurement, for example, corner reflector, big sphere and small sphere, how well and how accurate our model is. By default, we have here given an accuracy of close to 100% with a very tiny loss. So therefore, I would expect we will get here very good predictions. So if I play the measurement, and I can also take here an A-scope just for the sake of visualization. So here, let me put it here. You can connect also an A-scope to see. And we play the data of a corner reflector, for example. And you can see here the prediction. It tells you it is a corner reflector. This is the live measurement that we have done, which we later recorded. And we can play, for example, the measurement of a big sphere, which will be slightly different. And you see the prediction here is big sphere. If we would go and play the test data coming from the small sphere, you will see we have again a correct prediction of our small sphere. We have carried all this measurement on a robot, which is rotating in the same position. That's why you always see a peak with different magnitude levels at position around 1.8 meters. And this simple model can give a very high accuracy. Now, this is a quite simple model with which we can get, so to speak, this high accuracy. Once we have more challenging measurement, we can add even more blocks to be able to have a more efficient training and better result. So this will be it for this video. In another video, we will go through some more complicated examples and present you with some other blocks. Thanks for watching